Hi everyone. I wanted to start off with a review of intercepts and symmetry of graphs. So when I say intercepts, I mean X and Y intercepts. So hopefully you remember that X intercepts are just the spot on the graph where the graph is going to cross the x-axis. In order to find it, you want to set y equal to 0 and then solve for x. Y-intercepts are just the opposite, so this is where the graph crosses the y-axis. So in order to find them from a function, we want to set the x equal to 0 and then solve for x. So let's do an example. If we have the function y equals negative x squared plus 4, in order to find our x and y intercepts, I'm going to start off by finding the x-intercept first. So I'm going to set y equal to 0 and then solve for x. So to solve for x, I probably want to get x by itself. So I'm going to add x squared to both sides. So I end up with x squared equals 4, square root both sides. Then don't forget, when you square root both sides of something, you always end up with a plus or minus. So at the end, I get x equals plus or minus 2, which means we have two x-intercepts. Our x-intercepts are going to be at 2, 0 and negative 2, 0. Okay, moving on, y-intercepts. I'm going to set x is equal to 0. So y equals negative 0 squared plus 4. Well, negative 0 squared is just 0 plus 4, so y equals 4, which means we have a y-intercept at 0, 4. Okay, that's all I have for x and y intercepts. Hopefully that refreshed your memory a little bit. So then moving on to symmetry of graphs. When we talk about symmetry of a graph, there are 3 different types. So we want to look at symmetry with respect to the x-axis, the y-axis, and the origin. So when we talk about symmetry with respect to the x-axis, that just means your graph is symmetric over the x-axis. So an example would be if we had a graph that was a sideways parabola, oops, like that. So if it can be flipped over the x-axis and still match the other side, then this is symmetric with the x-axis. Y-axis would be the other way. So if you can flip it over this way. So an example would be like a absolute value graph. Remember, absolute value graphs are always V's. So if it was like an upside down V or whatever, and the vertex of it was on the y-axis, then it would be the same on both sides. With the origin, that's the one that to me is kind of where you can rotate it. So an example would be the cube root graph or the x cubed graph. Either one of those are both considered symmetric about the origin. So if I took the portion that was in the top left and kind of rotated it around the origin, I would end up by 180 degrees, and I would end up with the same graph on the opposite quadrant. So that would be respect to the origin. So with a graph, it's really easy to tell which one of these works. If you're just given an equation, we still want to be able to tell their symmetry without having to graph it out every time. That's kind of annoying. So let's say we're just given an equation. F of x equals 2x cubed minus x. And we don't know what the graph looks like, nor do I want to really graph it out. So in order to test for a symmetry with respect to the x-axis, what we want to do is plug in negative y where you see y. And then you're going to simplify. So instead of f of x, that really just is y. So I'm going to plug in negative y there instead. And then at that point, we're trying to see if the simplified version after I've plugged in negative y matches the original. So we always want to get y by itself. So I'm going to divide both sides by -1. So now I have y by itself. It does not match the original because now my signs are different. So because of this, that means this equation is not symmetric with respect to the x-axis. Okay, so now let's test for symmetry around the y-axis then. In order to do that, we're going to plug in negative x where you see a regular x. So if my equation was f of x equals 2x cubed minus x, then anywhere where I see an x in the equation, I'll just substitute in the y for the f of x again. It'll be 2 times negative x cubed instead, minus a negative x. So everything else stays the same, all the signs. It's just, instead of writing x, we're doing negative x, and I keep putting them in parentheses so that I can keep track better. But here I want to simplify this as much as possible. So when I do negative x cubed, negative x times negative x times negative x is still negative. So that'll give me negative 2x cubed. And then minus a negative x gives me plus x. So again, this simplified equation does not match the original. So again, this is not symmetric with respect to the y-axis. Okay, so then the last one, if we're testing symmetry with respect to the origin, then we're going to plug in both negative x and negative y. So from our original equation of f of x equals 2x cubed minus x, it'll now be negative y instead of just f of x. And then I'm plugging in the negative x like I did for symmetry around the y-axis. And if I simplify that, I end up with negative y equals negative 2x cubed plus x. And then I want y by itself, so I'm going to divide everything by -1, which gives me a positive 2x cubed minus x. And that one does match the original. Yay, we did it. So that means this is symmetric with respect to the origin. Okay, we did it. So that's how we're testing it every time. So I kind of remember it as plugging in the opposite letter. So when you're trying to test for symmetry around the x-axis, you're going to plug in a negative y. If you're testing for symmetry around the y-axis, you're going to plug in a negative x. So do the opposite letter. And then origin is that one, because it's like rotated, you're going to do both negative x and negative y. I just want to do one more example with you guys, and then that's it for this section. So with my example, I want to do slightly more complicated one because it looks kind of weird. So we've got xy squared equals -10. So same thing, we're going to test the 3 different situations. I'm going to start with the x-axis again. So that means I'm plugging in a negative y. So this will be x times -y squared equals -10. Well, negative y squared, if I square something negative, I still end up with positive. So x times something positive is still a positive xy squared equals negative 10, which, yay, matches the original. So that means this is symmetric with respect to the x-axis. Yay. Okay, let's test the others. So keep in mind, just because you've done one of them and it is that one, doesn't necessarily mean that it can't be more. You can be more symmetric. So if you think of like a circle around the origin, a circle is symmetric like in every direction. So that's an example of something that is symmetric to the origin, the x-axis, and the y-axis all at the same time. So that's why we have to test all three every time. So for the second one, let's do with respect to the y-axis. So we're going to plug in a negative x. So it'll be negative x times y squared equals negative 10. But then simplifying that down, I end up with negative x y squared equals negative 10. And obviously that does not match the original. So no for the y-axis. Okay, last one. If we did both, plugging in negative x and negative y. So now I'm going to have negative x and plug in negative y, but the negative y gets squared. Negative y squared still gives me positive, so then it'll be negative x times a positive y squared, which gives me negative xy squared. And that does not match the original, so this is a no for the origin as well. So the only one is that it was symmetric with the x-axis. It's also possible that it's none of them. So that's kind of disappointing when that happens because you did all this work and none of them worked. But just know that that is possible. Okay, that's it for this section. Bye.